The hardest part of computer programming isn't converting your concepts into code. It's figuring out how to solve a problem. Once the solution is on hand, it's just a matter of translating the approach to a programming language. In this video, we'll solve a sample problem using a systematic approach. Let's think aloud. There are 2 quizzes and 2 exams, each worth a certain percentage of total points. We know the scores for Quiz 1, Quiz 2 and Exam 1. We need to find the minimum score on Exam 2 to get an A in the class. If we ace them all, obviously we get an A. If we score the bare minimum of 90, we still get an A. This means, we get an A if the sum of the scores is greater than or equal to this value. Set up the equation like this and solve for Exam 2. Right? No. This solution assumes that quizzes and exams are weighted equally. They are not. We need to normalize the scores. We do this by multiplying each score by the corresponding weight. Let's run a quick test. If we ace them all, we get a total score of 100. That's an A. If we score 90 in all, we get a total score of 90. That's still an A. If we score 89 in all, we get a total score of 89. That's a B. Okay, this seems to work as intended. And here's our equation. E2n is the normalized score of Exam 2. We need to denormalize it before we output the value. We do this by dividing E2n by its weight. In the beginning, we introduced an incorrect solution on purpose. To demonstrate how quick thinking can lead to a logic error. Logic errors are hardest to catch. The program would compile and run just fine. It would produce the correct result in most cases, until someone notices. Unfortunately, logic errors are noticed often too late, after a disastrous result. This is why we want to spend majority of our time in the problem analysis phase. There are 3 steps to the program: input data, calculate, and output result. Let's look at each step, and we'll write pseudocode along with it. In step 1, we need to get the scores for Quiz 1, Quiz 2, and Exam 1. We'll ask the program user to enter them. And since humans tend to make mistakes, we'd better check the input. We ask the user to enter a quiz score. We need a loop to repeat the question until a valid score is entered. Inside the loop, we accept the user input. If it's valid, we exit loop. Otherwise, we ask again. We can reuse this code by putting it inside a function. Here we have a function. It has an input parameter, prompt. This is the text that asks the user to enter the score. It has a return value, score. This is the user input converted to a number format. And we copy and paste the previous code inside the function. Changes are highlighted in green. Thanks to the function, our code is simplified to 3 lines. Now we move on to step 2. We've already done the heavy lifting during the problem analysis phase. So this step is quite simple. In step 3, we want to output the score only if it's valid. A valid test score is 100 points or smaller. If the calculated score is larger than 100, there is no way to get an A in the class. And here's the pseudocode. Since we're testing the pseudocode, we can skip the error check. And the only requirement from the problem statement was that we calculate the minimum score. We improved the design by adding a validation check on the user input and the exam2 score. Test criteria includes two types of cases. In the normal case, we use an expected input and see if it produces an expected output. In the edge case, we use an unexpected input and see how the program responds. Here are the scores. And the normalized scores. Run the calculation to find the exam2 score. Exam2 score is valid, so output the result. Here are the scores. And the normalized scores. Run the calculation to find the exam2 score. Exam2 score is invalid, so output the message. In this case, the user input is invalid. Our function handles it by repeatedly asking for a valid score. We completed every phase except implementation. We'll leave that for the viewers to complete. You may think this whole process is too rigorous for a simple problem. Perhaps. But most problems are complex. Either you think through the problem ahead of time, or you waste time debugging your spaghetti code. The good news is that once you make a habit of using this approach, it will become second nature to you.